Let us start our discussion from astrocytes, because that is going to be the most important cell variety, very important cell variety people, astrocytes. And point number 1, astrocytes, as I just told you, they are absolutely abundant. They are just enormous. To be precise, you take one neuron, just one neuron people. Your brain has got billions of neurons, right? You just take one neuron. Every individual single neuron is surrounded by 6 glial cells, right? Every single brain neuron is surrounded by 6 glial cells. Now if that is the case, imagine what is the number of glial cells present in the brain. It's uncontemplable, right? So people, it's very, very, very abundant. Point number 1. Point number 2, when it comes to astrocytes, astrocytes in their cytoplasm has got a protein, and this protein is called as intermediate filament. Alright, this protein is called as intermediate filament. This word intermediate filament is more of a umbrella term. This includes a family of proteins, but very specifically in a neuron we got a filament called as neurofilament, and this neurofilament, it's not in the neuron, it is in the astrocytes people, I'm sorry for that. So it's in the astrocytes. This intermediate filament is going to be specifically called as neurofilament. What does this neurofilament do? This neurofilament is going to be in a huge quantity. It's going to be very abundant in the cytoplasm. As a consequence, you take up this astrocyte, doctors. You just take up this astrocytes, and these astrocytes has got axon-like projections as well. They also has got branchings and everything. Within these astrocytes, these neurofilaments are going to be arranged in such a manner that it practically makes the cell membrane to become very, very, very stiff. The flexibility is gone, it will not be flaccid, it will be tense, it will be more or less stiff and rigid, guys. So the presence of intermediate filaments is going to confer a kind of a stiffness to the astrocytes. And it is this stiffness of a astrocyte which is contributed by neurofilament, which is nothing but an intermediate filament, is one which makes the brain to remain solid. It's a cell, right? There is high possibility that the brain can be very, very soft and fragile and vulnerable, but no. What makes the brain to look solid? What makes the brain to look stiff and rigid on the appearance, or not being very flaccid or jelly? Protoplasm is just a mass of jelly, that is all. So you should have a jelly-like kind of feel when you palpate brain, when you touch the brain, but no, it will not be. The brain looks solid, the brain looks very, very stiff and organic, and the reason is astrocytes. Astrocytes do have plenty of neurofilaments that gives the stiffness to the cell, and that's what makes the brain to look stiff and be stiff, guys. That's point number 3, stiffness. Point number 4, astrocytes in their cytoplasm has got plenty of storage material, and this storage material is going to be glycogen. So in the astrocytes there is going to be plenty of glycogen, and this glycogen present in the astrocyte is going to act as a source of glucose for neighboring neurons. These neighboring neurons will be need of glucose for their metabolism and everything, and that glucose need is aptly met by the glycogen coming out of the astrocytes. And how is that going to happen? Consider we got a neuron very close to this astrocyte, and there is going to be gap junctions, people. You know this, right? Gap junctions are cylindrical proteins made of connexons extending from one cell to other cell. So there is going to be a small break in the glycogen, and this broken products of glycogen will be conveyed from one cell to the neuron, and this neuron is going to take up the glycogen, which is going to use it for its metabolic purpose. Alright, that's the way through gap junction astrocytes ensures the neighboring neurons metabolism being healthy and everything.